All right, homework out if you would please, and books open to page 124. Part of your homework was to rewrite the sine of 290 degrees in terms of the cofunction of a positive acute angle. Ethan, walk us through what you did here.
You can only use 90 and 270.
Good. For cofunction, you're using either 90 or 270, or in radians, pi over 2 or 3 pi over 2.
So I put cosine under and then just put 20.
Well, but we should take the time to be showing our work, right?
270 plus 20.
Right, rewrite this as a sum of two angles, one of which is either 270 or 90, in this case 270 plus 20, so it becomes
Cosine 20.
But ASTC,
negative.
Negative cosine 20. For the next one, the cotangent of 185 degrees. And we wanted to rewrite this in terms of the same function of a positive acute angle. Chris, talk us through it.
You have to use 180 or 360. I ended up going with 180 to get cotangent of 5.
Well, 180 degrees.
Minus,
how about plus?
Plus 5.
There we go, which becomes?
Cotangent of 5.
Positive or negative?
Negative.
Quadrant 3 cotangent's positive, ASTC. So positive cotangent of 5 degrees. How many had the same answers on these two problems?
On the right side, that's like minus 2 points.
Whatever you want to think. Questions on this? All right. Let's take a look at page 124, number 44 now. And we were given the secant of pi minus phi times the secant of pi plus phi minus the cosecant of pi over 2 plus phi times the cosecant of 3 pi over 2 plus phi. Jamie, walk us through first step.
Let's see. I labeled which quadrant each one was in.
Good. Normally we'd want to make sure the quadrantial is listed first, but they already did that. Normally we'd want to make sure the quadrantials are all positives, and they already did that. So we're ready for quadrants, and you found quadrant
1.
Ooh, pi minus something?
Oh, quadrant 2.
Quadrant 2.
And that's gonna be quadrant 3. Quadrant 2. And that's quadrant 4.
All right.
And then it's secant. Oh wait, well you would switch it because you would not switch it. So it's going to say it's a secant of phi.
ASTC.
Negative.
Good. This is going to become negative secant phi. This has same function, so keep the secant and the phi. Quadrant 2, it's negative. What about the next one?
You would keep the secant and its phi. And it would be negative.
In quadrant 3, secant's negative. Let's keep this minus sign right here. Let's go to the next one. Quentin.
Secant phi.
Good. We're changing to the cofunction, which is secant. Keep the phi, and in quadrant 2, cosecant is positive, so keep the positive. And then for the last one?
Secant phi is negative.
Good. Secant phi, again, cofunction, keep the phi, and then quadrant 4, negative. Then we try to simplify, Quentin.
So it would be positive secant squared phi minus negative secant squared phi.
But minus negative really could just mean plus. So we have secant squared phi plus secant squared phi.
2 secant squared phi.
And that's about as simplified as I think we're going to make it. How many had 2 secant squared phi for your answer? Ooh, questions. All right, let's take a look at number 50.
I got the cofunction the same mixed up.
Okay, remember x-axis, same function, y-axis, cofunction. Let's take a look at number 50. It was a verification, verifying the cotangent of 3 pi over 2 plus 2 alpha equals 2 tangent alpha over tangent squared alpha minus 1. And on the surface, if I asked, an elementary student, which side looks more complicated, they would probably say the right-hand side because there's this ugly fraction. But anytime you have a sum or difference, that always means it's more complicated. So we're going to start over here on the left. And what do we do here, Ethan?
Well, we can change cotangent to tangent.
Because this is y-axis, which tells us cofunction.
And then this is 2 alpha. equal. But there's two alphas.
Well, hold on, we're not ready for that yet. What quadrant?
Quadrant 4.
Quadrant 4. So, negative tangent 2 alpha. Now, Chris, you started to mention this whole 2 alpha. What did I tell you we should do when we see a 2 alpha or a 2 theta or a 2 anything?
Do the alpha plus alpha.
Good. Write it as alpha plus alpha. So we turn this into a sum or difference identity. And what is the sum difference identity for tangent, Jamie?
That's tangent. I can't remember the name for this symbol.
It's alpha, but
Okay, yeah, alpha plus or minus.
in this case,
Plus tangent alpha all over 1 minus tangent alpha times tangent alpha.
and since all of this has a negative in front, we'll put a negative in front. Now what should we do? Quentin?
Combine the tangent alpha or in the numerator.
To get?
2 tangent alpha. 1 minus tangent squared alpha.
And at this point, we are really close to what we want there. I just want the 1 to be negative and the tangent squared to be positive. Thoughts, Ethan?
Could factor out a negative?
If I were to factor out a negative, so in the numerator, leave the 2 tangent alpha, but in the bottom, let's pull a negative out to get
Positive. Oh. Negative tangent.
We're pulling a negative out of this right here.
I was looking at the wrong thing. Negative 1 plus tangent squared. Oh, I was looking at the.
And then, finally here, class, I've got a negative denominator and a negative fraction.
Cancel.
They cancel. Anytime there's 2 negatives in a fraction, they're going to cancel. And I could just simply flip-flop the negative 1 plus tangent squared.
Tangent squared plus 1.
Plus 1?
Minus 1.
Negative 1. And we're going to leave, of course, the 2 tangent alpha in the numerator, and that's exactly what we wanted. 2 tangent alpha all over tangent squared alpha minus 1, and our check mark. Just barely ran out of room on the chalkboard for all this. I took up too much space up here. And how many got this? All right, good. Couple of you. Few of you. Questions?
Well, actually, it was on the right side.
Oh, bless your heart.
It wasn't that bad.
Of course, Quinn took the long way.
How in the what would
Did you get it?
What did you do on the other side?
What'd you get?
On the other side, I made that tangent alpha plus tangent alpha.
Okay, so you kind of expanded this to tangent plus tangent.
That's it.
That's it. I made all of it tangent times tangent plus tangent, or tangent times alpha plus alpha, and then.
Does it make sense? What would have probably been a more direct way to do it? Does this make sense?
Somehow it came up. Right.
Did you get the answer?
All right, let's take a look at number 53. All right, let's take a look at 53 now and see how we did on that verification. And here we had a 1 over sine squared kappa minus 1 is equal to the tangent squared negative kappa negative 3 pi over 2. And let's start with Chris this time. Which side is more complicated?
I chose the right side.
The right side is because there's a sum or difference, but there's an issue with the right-hand side.
Pull out the negative.
Yeah, and at the same time we pull out the negative, we also ought to flip. So let's put the negative 3 pi over 2 first, but as we're factoring out the negative, it's going to become
3 pi over 2 plus k.
Plus kappa. So we're going to factor out the negatives, they both become positive. There's my negative here, 3 pi over 2 plus kappa as we reverse. And I went ahead and wrote the squared out here because it is the tangent of all of this, all squared. It's just another way to look at it. Next, since we have the tangent of a negative angle, Jamie.
It would be negative, like tangent of 3 pi over 2 plus squared.
Kappa, all squared. But, thoughts, Quentin?
He went the wrong way.
He chose the left side.
You swear? No.
We could, or I've got this 3 pi over 2, this y-axis quadrantal.
So, cofunction.
Cofunction. And so what is the cofunction of tangent?
Cotangent.
Cotangent of,
Kappa.
but what quadrant would 3 pi over 2 plus kappa be in?
4.
Quadrant 4, which means it's going to be,
Negative.
but there already was a negative, so it really becomes positive. And positive cotangent kappa squared would be more easily rewritten
Cotangent squared.
cotangent squared kappa. At this point, we could try to go over to the other side, or we could leave it and recopy and try to get everything to cotangent squared. It's up to Ethan.
That's the answer.
Just kidding. Oh, it's not.
1 over sine squared kappa equals cosecant squared.
Well, hold on. So that means we're going to recopy this then, since you want to work on this side now. Let's recopy, and now let's go. You said this becomes
Cosecant squared kappa.
minus 1.
And then cosecant squared kappa minus 1 equals cotangent squared kappa. Correct?
Let's think. What's the actual identity the way we memorized it? Class?
Oh,
1 plus cotangent.
yeah.
So can I get a cosecant squared minus 1? Yes, and it would indeed equal cotangent squared. So yes. All right, just like to check and make sure. Of course, we obviously need to have those memorized really well, but it checks out. And there we go. Questions on number 52, or 53, excuse me.
Quiz.
All right, take a look at number 52 together now. Go ahead and copy that down if you would, please.
Is that the big one? Oh, the 54.
54 is confusing. Copy down 52. We've got a cotangent, 3 pi over 2 plus beta. Cotangent, pi minus beta, minus cotangent, pi over 2 plus beta. Cotangent, 3 pi over 2 minus beta, equals negative 1 over sine beta negative 1, sine beta positive 1. All right. Chris.
I don't know how to do this one. I'm joking. I didn't have an option. Here, let me finish writing it down. Alright. So on the bottom, you have a sum difference. Not sum, yeah, we'll
Ooh, okay. Here's my only thought. If I start on this side, because at some point I've got to recopy all of that. I am so
We're not
lazy.
doing that.
I do not want to recopy all of it again.
On the left side.
Good, good, good. That's what I was thinking.
So they're already all positive, already have all the functions outside. So you can go ahead and start with quadrant. Alright, quadrant in the first one. So you're adding something at the quadrant 4. Second one, that would be quadrant 2. 2, 3.
All right. And same function or cofunction class?
Cofunction.
So
Tangent.
of
Beta.
and it's
Negative.
negative. All right. What about in the next one? Same function, cofunction?
Same function.
So
Cotangent.
of
Beta.
and it's
Negative.
okay. Then we have the minus. Don't lose the little minus sign there. And then for the next one, same function, cofunction. Cofunction. So
Tangent.
of and it's
Negative.
and for the next one,
Cofunction.
so
Cotangent. Or tangent.
of
Beta.
and it's
Positive.
all right. And let's see here. Let's go to Chris. Really wants to take over this one here. Okay, Chris.
Alright, then you're going to want to times the tangent to the cotangent. So that's going to give you tangent, or it's going to be positive tangent, cotangent of beta.
Well, tangent beta, cotangent beta.
And then minus, that's going to give you negative tangents, negative tangent, or positive tangent squared beta.
Now, we'll throw this thought out there, Chris. I've got a tangent up against a cotangent.
Make it 1 over tangent.
Yeah, what if at the same time we went ahead and rewrote?
I thought everything had to be shown. That's why I
Well,
said
we are showing. We're showing the negative times negative becomes positive. We showed that. We show the tangent, but we're also showing how the cotangent becomes 1 over
And then put the
tangent.
tangent beta over 1, cancel the tangents, cancel the 1s.
So we're careful.
1 plus tangent squared beta.
All right, let's go to Jamie. And Jamie, our left-hand side that was so massive has consolidated considerably.
And you could turn with a Pythagorean identity into the cosine square. Secant squared.
1 plus tangent squared equals secant squared. So this entire side just becomes a secant squared beta. Now, I'm going to go ahead and recopy this because this was easier to recopy than the other side was. That other side was just so nasty. All right, Quentin, we're changing gears. We're going to the right now. Like so many voters in New Jersey. And
Can I ask something? Did you know Amendment 4 guarantees a Republican form of government to the states, and now there's Democrats, so it's not technically
Republican form of government, meaning representatives and legislatures. All the states still have a Republican form of government. All right, so let's go to Quentin.
You're an
Alright, yeah, so the difference of square first, square left, with my sign.
To get?
Sine beta squared.
Full sine squared beta.
Yeah, minus 1.
All right, now thoughts on that sine squared minus 1, Jamie?
That's equal to cosine squared.
Is it? What's the actual identity?
It's the sine squared beta plus cosine squared equals 1.
So if I got a sine squared minus 1, can I even do a sine squared minus 1?
Yeah, you would have to do double switch, and that makes it equal to a negative cosine.
Okay, that's why it's good to write that off to the side. So this becomes negative 1 over negative cosine squared beta. Thoughts, Ethan? Back to you.
Positive.
I'm sorry?
Doesn't that thing positive?
Yeah, let's cancel to get just 1 over cosine squared beta. Which is, Chris?
Secant squared beta.
Which is now what I have on the other side. And as big and nasty as number 52 looked,
It was easy.
it really wasn't that bad, right?
It was easy.
Kind of like 54 is going to be. Let's take a look at 54.
I hate my life.
Let's take a look at number 54. See, it's not going to be so bad. It looks nasty.
There's a fraction. It's going to be bad.
There was a fraction in the last one.
There's a fraction with the identities.
8 things.
Yeah,
As the scripture says, you shall not surely die. Are you sure?
I so surely.
Why am I quoting the serpent? All right, let's take a look at number 54.
We have to write it down.
We got the cosecant negative lambda minus the cotangent of negative lambda times the cosine of negative lambda, all equal to, okay, we have the cosine of negative lambda minus pi over 2 times 1 plus the sine of 3 pi over 2 minus lambda times 1 minus the sine of 3 pi over 2 plus lambda all over the cosine of pi over 2 plus lambda times the cosine of 3 pi over 2 minus lambda. Boy, are you going to feel accomplished when you finish this one.
I'm going to feel suicidal.
do it yourself.
Hey, on a positive note, you already have the answer key.
What?
It's right over here. This is what it's going to look like when you're done.
Oh, okay.
Funny
It's just
guy.
like when you do a proof. You have the answer key already. When it says to prove, that's what you're going to get.
So that's being
All right, so let's go ahead and take a look at this together, and we should start with Jamie here and put her on the spot.
Cheese over.
Okay, well, you need to have the quadrantals at the start, so you need to change the cosine negative.
I guess so, don't we? Yeah. All right, so it becomes the cosine of.
Let's see, negative pi over 2 minus the lambda, and we could factor out the negative.
Okay, hold on there. So let's go down to the next step. I'm not going to copy all of that, but I'm going to do some other stuff with that. Let's come here, and you said factor out the negative.
Yeah. And it was the positive.
Okay, and then in the next step, which I'm not going to copy all of that yet.
It'd be cosine of lambda, and it's already negative.
Oh, hold on now. What happens to a negative
it goes
angle?
away.
It goes away, so it's just pi over 2 plus lambda. Let's leave that there for a minute. Let's do some stuff with the rest of this. I don't want to recopy all that, so I need to do stuff so I don't have to recopy it. I've got a 1 plus sine of 3 pi over 2 minus lambda. Let's make that 1 plus, let's see, 3 pi over 2, Quentin.
This is real.
3 pi over 2.
Cosine.
Ah, yeah, cofunction. So let's make this the
Cosine.
of
Lambda.
what quadrant?
Quadrant 3.
Ooh, and if it's quadrant 3, that means we actually need not a positive here, but a negative. So 1 negative cosine lambda. Let's come over here, Chris. I've got, again, a 1 minus sine, and it's got 3 pi over 2.
1 minus cosine.
Well, okay, so the 3 pi over 2 tells me
Oh, it's in the mean.
cofunction, so cosine of
3 pi.
Of- but what quadrant?
4.
4, where sine is,
Negative.
but I already had a negative,
So just make it positive.
so we go to 1 plus cosine lambda. All right, and then in the denominator, Ethan, I've got pi over 2, so that tells me
It's a cofunction.
So,
Sine
of
lambda
quadrant
2
so,
negative.
all right. And then right here, Jamie, back to you. We've got a full circle now.
That's you'll do the what is it, secant?
Ooh, what is 3? Remember, 2 means cofunction. What's the cofunction of cosine? Secant's the reciprocal. Sine is the cofunction of
A lambda.
quadrant.
3.
So-
that's negative.
All right. Now, we already kind of did this step, but let's come right here. 1 minus cosine lambda, 1 plus cosine lambda, Chris.
Boiling.
We could, or maybe faster way.
Sum difference.
Sum and difference gives us.
1 minus cosine squared.
Oh! All right, and wait, you know what? Let's stay in the numerator. What is 1 minus cosine squared?
That's the Pythagorean theorem.
It's Pythagorean identity, right?
Yeah.
But the actual Pythagorean identity, remember, is sine squared plus cosine squared equals 1. Can we make a 1 minus cosine squared?
No. Yes, move the cosine over.
Yeah, so it would leave us with a
Sine squared.
sine squared. So this just becomes sine squared lambda. Now let's come to the denominator. I've got a negative sine squared lambda and a negative sine squared lambda. Quentin?
Positive sine squared.
This just becomes a positive sine squared lambda, which of course, that means, you know, it's just positive sine squared lambda. But thoughts on the next step here, class?
Cancel.
These are going to cancel, leaving me with this, but pi over 2 tells me
Y-axis, so cofunction.
cofunction, so
Sine
of
lambda.
quadrant
Quadrant 2.
so,
Negative.
and I'm done on this side.
Oh. Okay.
So
I thought you
now,
said we weren't going to want to die after this.
you're not. So now, we need to recopy the other side. Oh, let me recopy it here. All right, because we're done. So we'll recopy the cosecant negative lambda minus the cotangent of negative lambda times the cosine of negative lambda. And I kind of worked myself right out of room here. Okay, so over here, we're not going to mess with the right side anymore. We'll leave the negative sine lambda for now. Coming over to the left, the only identities we have on the left are negative angle identities. What do I do about the cosecant negative lambda, class?
Pull it out.
So,
Negative cosine lambda.
negative cosecant lambda minus, what about the cotangent negative lambda? So,
Negative cotangent lambda.
what do I do about the cosine negative lambda?
Positive cosine lambda.
So just cosine lambda, because the negative falls off. Sit straight, Chris.
You can make the two negatives a positive.
Okay, so this becomes negative cosecant lambda plus cotangent lambda cosine lambda. All right, let me get some more chalk. That burned up that stick of chalk. Yeah, it's like I always say, you lose some, you lose some. All right, thoughts?
Cotangent cosine over sine.
It is cosine over sine, so if I rewrote this as cosine lambda over sine lambda times cosine lambda, maybe put the cosine over 1, okay?
And you just get cosine squared over sine.
Cosine squared lambda over sine of lambda. But let's not neglect the negative cosecant lambda over here.
Bring it down.
I could, but I'd rather do something different.
Change it to
1 over sine.
Negative 1 over sine lambda.
Then you have negative 1 plus cosine squared over 2 sine.
Well, careful.
Sine, just sine.
Right, just keep the common denominator. So I have negative 1 sine lambdas plus cosine squares over sine lambdas gives me negative 1 plus cosine squared all over sine.
I want to do Pythagorean theorem on top, but I don't know if you.
Yeah, what's the actual identity?
Sine squared plus cosine squared equals 1.
Could I get a negative 1 plus a cosine squared?
Double switch the sine.
That would give me a negative 1 plus cosine squared equals
Sine squared.
negative sine.
negative sine squared. So this would give me a negative sine squared lambda over
sine. And
sine
then you
lambda.
cancel one of the sines, and you get negative sine.
And we put the all-important check mark there. And there is number 54.
Imagine you were off on the wall the entire time or something.
Now
No, I was just making sure I got it all on there.
Now what you did is right.
So when students ask me in junior hires, because they ask silly questions like this of, do you ever work a problem that covers the entire chalkboard? Why, yes. Yes, I do. We just did.
Is this the only one we're doing all year?
Well, you'll find out. All right, questions on this.
Crying.
Questions on this.
Quiz.
All right, clear desk except for a clean sheet of
Why do you
paper
have to say something?
and a pencil. And calculator's optional, but it might make you feel better about yourself.
You know I'm the quiz prophet. Stop playing with me.
Bro.
Sheet of paper, pencil, calculator, everything else away. First and last name at the top of your paper, along with today's date, which is 11/5/21.
You get the rest of the hour to finish the quiz.
No, you don't get that much time.
Oh, come on.
You won't have one like 54 on the quiz if that makes you feel better about life.
We won't?
No.
Promise?
Yeah. All right.
Just kidding.
You'll have one more.
Just April Fools. Just
Have one even bigger. You thought Pharaoh was hard. Was it Jeroboam or Rehoboam? Rehoboam. You thought my father was tough on you.
You thought Nero was bad. Wait till you see Nadasky.
First and last name today's date. This is quiz 17. You're on the back side of your paper, Chris. The hole's on the other side. All right. Quiz 17. Don't ask what happened to quiz 16. It vanished. There is no quiz 16. We go straight from quiz 15 to quiz
You
17.
must not like that number.
Quiz 17. It's a perfect square. It's just a little too symmetrical. All right.
I just wrote 16 for the year. So.
That was a good year. All right.
For real.
For the Colts, no.
All right. First and last name, 11/5/21 today's date. Quiz 17. Let's take a look at the quiz very quickly. 1 through 3. Rewrite them. I would recommend you show your work so you can receive partial credit if you happen to make a careless, stupid mistake. Number 4, you're simplifying. Number 5, you're verifying. Go ahead and get started.